If you look at electric field of a point charge, it is what value, magnitude? Electric field of point charge, A Q by R square. So E is proportional to 1 by R square. But if you look at short dipoles, the electric field is proportional to 1 by R cube, isn't it? So do you see, electric field is not always proportional to 1 by R square. In some cases, like a short dipole, electric field is proportional to 1 by R cube. Got it? So please make sure you understand this point. The more you apply your brain, the less you have to use your memory. તમારામાંથી ઘણા એવું કહેશે કે જો આ યાદ રાખવાનું એવું કીધું સરે કે આ યાદ રાખવાનું ને ઓલું યાદ રાખવાનું મેં એકય યાદ રાખવાનું નથી. આઈ એમ સેઇંગ યુ એપ્લાય યોર બ્રેન. આ ફોર્મ્યુલા હોય તો એટલી તો ખબર પડે કે આમ આવે, અને આની ફોર્મ્યુલા યાદ હોય તો એટલી તો ખબર પડે કે આમ આવે. Please don't have to remember. Got it? Well, so keep this in mind, because I have seen questions like that earlier, okay, in MCQ. Now, so after having covered torque on a dipole, so we are done actually with the dipole thing. Now we'll go over to the next, that is flux. But to understand what is flux, first we will understand what is area vector. Okay, first we'll understand what is area vector. Name itself seems contradictory. Area is a vector. No, area is a scalar, but area vector is a vector. Alright, area is a scalar, but area vector is a vector. So to make you understand what is area vector, I am going to present a very unique design of umbrella. Okay. This umbrella, we have named it vectorella. Alright? Designed by me. Okay, patent pending. Right. So what is this vectorella? It's a very useful tool to understand area vector and then to understand what is flux as well. Alright. So you can see this is like a typical umbrella, isn't it? But it's flat. Okay, and it's got a nice handle. The handle is actually like a vector, hence the. Okay, so what are the properties of this vector that we have drawn? You can clearly see that this vector is perpendicular to the surface. Yes or no? Sure, you understand what I'm saying? Take a book, any pen muko. So that perpendicular to the surface, right? This is the handle. Okay or not okay? Very. So this tells us what is area vector. Area vector is defined as magnitude area. Wow. Okay, nothing surprising about this. Magnitude is area, and direction is the normal direction. N hat stands for unit vector in the normal direction. In the direction normal to the surface. Right? So this is the formula, or this is the idea of the area vector. So let's have a look at one more complication possible. You see, you can draw the normal this way, or you can also draw it upward. Do you understand? Yes or no? Yes. Which way to draw? Right now, I'd say you have liberty. You can draw it either. Okay? Soon, I will snatch that liberty from you. Okay? Right now, I'm saying that you have liberty. You can choose it here or you can choose it there. But very soon, that liberty will be gone. The freedom will be gone. Right? You will not be able to do it either way. Only one will be right. Anyways, so that's the area vector. But you see, this is practically only true for flat surfaces. What we have discussed so far about area vector, that is only true for flat surface. Now, let's take a little bit of example for this so that you get used to things. Suppose this is the XY plane and here is Z axis. Okay, let's say I put a disc over here in the XZ plane. Look at that corner. Again, need to put it this. That is Z axis. This one is X axis. What? So this is lying on the floor. That is on XZ. Right? Suppose its radius is, let's say, 1 meter. Then can you find its area vector? Find its form. What will be its area vector? What will be its area vector? Use karo. What direction? First of all, decide direction. Which direction? Normal to the normal to the surface. So क्या है? यहाँ ये डिस्क मुको तो normal क्या है? Positive y or negative y, any one. Is that clear? Clear or not clear? Imagine करी सको यहाँ डिस्क मुको तो ऊपर जाए ना कहाँ नीचे जाए. Okay, normal would either be upwards or downwards. Let's take positive one. So direction is j cap. Fine. What about magnitude? Magnitude is same as area of that surface. So how much? How much? Pi r square. The final answer will be A vector is equal to pi into 1 square. Right? And unit will be meter square. Don't worry. It will definitely have a unit. Understood the method? Pi in square j caret or pi j caret. Clear? Learn how to find the area vector or not now? Again, like I said, the area vector will be normal to the surface and it will come either up or it will go down, but we are choosing the one that goes up. Fine. Everyone there? Great. Now, what to do for curved surface? Let's talk about that quickly. What if it's not flat? Then there is a problem. See, the problem is that when we talk about a curved surface, let's say this is some curved surface. Can you imagine what I've drawn? Okay, you guys, I'm curved. So now, if I draw a normal at this point, it would be in this direction. But over here, it would be in a different direction. Yes or no? Yes. So can I draw a unique normal? Can I draw only one normal? Possible is nothing. You get what I'm saying? Yes. It is not possible to draw unique normal. Everything clear? Okay. So what do we do there? When things are changing, we have infinitesimals and then integration to do, right? So what we do is we divide these into very tiny parts, infinitesimal parts like this, and then for each tiny part we can draw a small area vector in the normal direction. So basically dA1 vector can be written as dA1 n1 hat, dA2 vector means for second one, let's say here is second one, like that. Okay, so dA2 n2 hat. Did you understand? For all of them, for each tiny part, we can draw a separate area vector. Got it? Clear or not? Please have not understood. Okay. If you want to ask a question, you can ask. If you don't ask, I will move on. Not understood is not a question. It's a question. What have you not understood? You tell me. So your question is why I am writing it in this form? Starting with the area vector के दे रखे तो आई नहीं आप लोग से बच्चे ने लोग से it's just a small area. That's the only difference, isn't it? Earlier we took a flat surface, so we can take a larger area. Now here we cannot take the whole thing together, correct or not? Because everywhere the direction will be different. So what do? We break it into tiny parts and we deal with it individually. Got it? So that's what these are. So this is how you find multiple area vectors, by dividing them in parts as necessary. Got it? So whenever the surface is not flat, you have to do this. Whenever the surface is not flat, you have to do this. Okay, fine. So that's the whole story about area vector. I'm going to erase this. ઇન્ટિગ્રેશન આનું નહીં કરવાનું, એની જરૂર નથી. આપણે સરફેસ એરિયા નથી ફાઇન્ડ કરવાનો, રાઈટ? ઓકે, next. Now we are ready to understand what is electric flux. Flux nahi, electric flux. Okay? Now first of all, the literal meaning of the English word flux means to flow or pass through. What does flux mean? To flow or pass. Whenever something is passing through or flowing through some point, we say there is a flux. Right? So electric flux actually refers to here the number of electric field lines. Electric flux is something related to number of field lines passing through a given surface. Number of field lines passing through a given surface is proportional or is related. You can use either word, no problem. Is proportional or related to the electric flux. Okay? For that surface. Let's complete the sentence. For that surface. It's possible you have not understood anything. I don't mind. Okay? I'm not at all worried if you have not understood this sentence. So first of all, without even trying to explain this, I'll go to an analogy. Analogy means we will talk about something that is similar to this, which you will definitely understand. What's the problem with this is we cannot see field. You understand? We cannot see field or field line. Field lines are obviously not there, but field is there, but we still can't see it. That's the problem. That's why it's difficult for us to imagine what this is telling you. So we'll go to something that we can actually see, and very much in this weather, rain. So whenever there is rain, we have to use vector element. Is that okay? So it's the time to use the specially designed umbrella. Alright, so here is vector. Let's say rain is falling in vertical direction only. Okay, no wind. And no one is going to run in rain. Alright? It's not those relative velocity problems. Clear? Let's say there is uniform rain everywhere. Okay, starting with uniform. Now, I'm going to ask you a simple question. The rain, the amount of water that falls on this surface of the vector element depends on number one, the area. Yes or no?
Yes. Yes.
Very intuitive to understand. જેટલો મોટો area એટલો the rain પડશે. Yes or no in a given time. Clear or not clear?
Yes.
Very. A. Second, what else do you think? How much water falls on this depends on?
Speed.
Speed of rain. There is a better word. Speed of rain only means droplets are falling fast. એનાથી ફરક ન પડે ને. It is called intensity of rainfall. Think about it. What is meaning of intensity of rainfall? Whether it is light drizzle or is it heavy rain, or is it raining cats and dogs? એવું કહેવાય ને એને સાંભળ્યું. When it is raining very very heavily, we say that it is raining cats and dogs. Don't worry, not a single dog will land on this umbrella. All right, clear or not clear?
Yes.
Okay, so basically intensity of rain means how much water is actually falling, right? Okay, whether is it light rain or heavy rain. Got it? Sure, you understand it depends on this. Fine, everyone? There is a third factor. Think about it. Rain will always fall vertical. But what about the umbrella? What about the umbrella? What about the umbrella? Come on. Can you make it tilted? If you tilt it, what will happen? Will amount of water hitting the surface remain same even if you tilt it? Okay, વધી જાય. વધી જાય કે ઓછું થઈ જાય? ઓછું થઈ જાય? Sure. So if you keep it like this, the way I have drawn, will it be maximum amount of water hitting or minimum amount of water hitting? Maximum. Very good. So right now, do you see that rain is falling in this direction and the handle is also in the same direction. So what's the angle between the direction of rainfall and the handle? 0. So we are seeing that somehow it depends on the angle, and not only that, we are seeing that when this angle theta suppose is 0, then at that time we get maximum amount of water hitting the surface. Yes or no?
Yes.
Yes or no? Okay. Right. Is it possible that not a single drop of water hits the surface of the umbrella? Possible? How? It equal to 180. 180 ke 90? 90. Is that clear? If 90 goes to that, all the rain water will go from the side. Correct or not? Does everyone realize that? Correct. If it would be vertical like this, then the handle, let's say, goes that way. Alright? And then all the raindrops are going from the side. Okay, they will not hit the surface. Did you understand that? Okay. Right now, what's the angle between the handle and rainfall direction? 90. So when the angle theta is 90 between rainfall direction and handle, at that time what happens? No water hits the surface. Got it? Yes or no?
Yes.
બસ તો તમને સમજાય ગયું what is electric flow? ન સમજાણું? સમજાય ગયું કે ન સમજાણું? What does this tell you? Number of field lines that are passing through a given surface, right? So now let's remove the analogy and make it actual, let's say electric field. So let's say these are the electric field lines which are there in this electric field. Let's say uniform. Okay, simple case, uniform. Right now, do you realize that some field lines will be passing through this surface, just like water tries to pass through that surface? Sure. So if this angle theta between electric field and area vector, this is area vector, right? Handle was area vector. Yes or no?
Yes.
If the angle between electric field and area vector is 0, then what happens? Maximum number of field lines will pass through the surface. Correct or not? Maximum number of field lines will pass through the surface. Got it? Sure? Okay. So it will have maximum flux. Yes or no? Number of field lines passing is what electric flux is related with. Right? So this will give maximum flux. On the other hand, when we make it like this, what will happen? The electric field field lines will go from the side. Not a single field line will hit this surface or pass through that surface. So then flux will be zero. Very good. So now I hope you realize that electric flux for a given surface based on this idea depends on three things. Number one, obviously area. This is very childish. Bigger area, more field lines will pass. Yes or no?
Yes.
कोई एमा doubt નથી ને? Very. Second, now it's not rainfall. Intensity of electric field. The intensity of electric field is how strong the electric field is. Okay, basically, if electric field is strong, listen to this. If electric field is strong, do you realize you have to draw field lines close to each other?
Yes.
Yes, any property. Distance between field lines indicates how strong is the electric field. Yeah,
Yes.
so that means if the field is strong, that means there is more flux. Yes or no?
Yes.
If intensity of electric field is more, E, intensity of electric field and E, if E is more, then field lines have to be close to each other. Then wouldn't more field lines pass compared to another case where field is very weak? Let's say very weak field. So thodical field lines pass to the right.
Yes.
Right? Who said you can't see flux? Now every time it rains, observe what? Electric flux. Got it? Okay. આ બધું combine કરી. Okay, these three factors itself give you a very nice formula. Symbol of electric flux is phi. Okay, symbol of electric flux is phi. So phi is equal to, what do you think? Phi depends on area, yes or no? More area, more flux, yes or no? Okay, more electric field strength, more flux. Correct or not correct?
Yes.
And now time for the angle. What about the angle? What do you think? What is such that at 0 it becomes maximum and at 90 it becomes 0? Yes, very good. તમે બનાવેલી ફોર્મ્યુલા મેં તમને કીધી હતી તો આવી ગઈ ને. So phi is equal to EA cos theta is the formula of electric flux. Okay, but yeah, there are certain conditions if you want to use this. Well, a basic formula. This is the definition of flux. So what's the definition of flux? Don't write this. This is not the definition. This is the definition of. Alright? Okay, there is one more way to write it. Do you realize if you have got E A cos theta and A is a vector, E is a vector. What should we write? What should we write? Our cos theta came out. Dot product. Very good. E vector dot A vector. When someone is very area vector to come so that we can do this as a dot. Got it? E vector dot A vector is the flux. Find is phi a vector or not? Is phi a vector or not? Is electric flux a vector or a scalar? Vector or a scalar? Vector or a scalar? Scalar, not a vector. Dot product. Dot product is also called work F vector dot dr vector. Scalar or vector? Scalar, because dot product always gives you a scalar. So flux is not a vector. Flux is a scalar. Don't forget. Right? See, don't I tell you again that basics are the main thing. Anyone who remembers that a dot product always gives a scalar doesn't need to remember that flux is a scalar. It will come naturally to you, don't you think? Okay? Fine. So what are the problems or what are the conditions in which we can use this formula? Okay, it's not always right, let me tell you. Here you would have seen that we have taken a very simplified version, right? So this formula is only true. This formula is only true if uniform electric field and flat surface. In any other case, this formula is wrong. Both conditions are there, mind well. Both conditions are there for uniform field and flat surface. So the field should be uniform and the surface has to be flat. So that these are not that. And what is theta? One very common mistake people make. Theta is angle between E vector, that is electric field, and area vector, that is A vector. Clear? Be careful with it. I'm a mistake I be careful. Okay? Now, let's go to the next thing. What to do for curved surface or non-uniform field? Okay? So part 2 of this. If the surface is curved, or field is not uniform or non-uniform. Okay, if the surface is curved and the field is not uniform, then divide and rule. That is, take the surface. This is some sort of curved surface or anything basically that's not flat. Anything, right? Random shape, no problem. Even the room. You see, room does not have a flat surface. Room is made up of 6 flat surfaces. Clear or not? Room is made up of 6 flat surfaces. Correct? 1, 2, 3, 4, 5 and 6. But room itself is not a flat surface. Correct? I hope you realize that room is not a flat surface. Some of you might disagree. You might say, sir, everything is a flat surface. Room is not a flat surface. Think about it. What is the meaning of flat surface? Where you can walk without ever changing your direction. That only can be flat. Yes or no? Let's say there is an ant. Ant starts to walk from here to there. Where it will reach over there, and if it continues to walk straight, direction will go in a flat. No. Alright? Anyway, ant is a very useful living being to understand about surface, right? Let me tell you. Okay, now here. So if it's like this, what to do? Let's say over here the electric field is E1, over here let's say it's E2, like this, at different places it will be different. So what we do is, we will divide this whole thing into so many tiny parts. For each part, we will take the area vector and the electric field and we will do a dot product. So flux for first one will be E vector dot dA1. Okay, flux for second part, this part will be E2 vector dot dA. Like this you continue. For third, fourth, fifth, sixth, seventh, eighth, like that. But if there are infinite number there, can we add infinite times? No, we have to do it by integration. Okay, we have to do it by integration. So, in general, the formula of flux is this. Did you understand? Instead of taking one area A directly, we have to take small areas, dA, 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 like that. So then we can do integration of the small flux. Actually here, if you want to write one more step, you can write it like this. Flux is integration of d phi. Now d phi means small flux through small area. So E dA cos theta. Right? This is the small flux through the small area dA. Right? Our work જેવું છે યાદ આવે છે dW is equal to, we used to write dW is equal to F vector dot dr vector, which is equal to F dr cos theta. And then if you want to find total work, then we write integration of F dr cos theta. Remember that? Okay? We write, but symbols have changed. The maths has not. Right? Well. So that's how you find flux for a curved surface or if the field is not uniform. This is a universally applicable formula. This is always true. That one is not always true. And you know, something that is always true is always difficult to use, isn't it? Right? એટલે જરૂર પડે તો જ ઇન્ટિગ્રેશન કરવાનું. બધા સમમાં ઇન્ટિગ્રેશન થી નહીં કરવાનું. If it's flat, try to use. Sometimes you can also divide the surface in parts. For example, room. Let's say room. If someone says find flux through this room, then we'll not do integration. No. What we'll do is we'll say, okay, first part, second part, third, fourth, fifth, sixth. All the six are flat. We'll do it individually. First, second, third, fourth, fifth, and then we add. So we get the total flux. Do you understand? Okay or not okay? So we use such simple idea, right? That is, we need integration only rarely, not every time. So please remember that. Okay. Well, so that's the meaning of electric flux, the definition, and the formula. Again, for flat surface and uniform field, phi is equal to EA cos theta. And for curved surface or for non-uniform field, what do you have to do? You have to divide it into small parts or indivisible parts, and then find individual flux and do an integration. Right? Okay? If જરૂરી છે બહુ રેરલી જાવ. Okay. ટેક્નિકમાં તો લગભગ એક સમાન. Okay, now let's go to the next thing. That will be a theory. Sorry. If you have the theory, solve it. Exercise question 15, I think. Exercise question 15, 1-5. Consider a uniform electric field. Yes, that's what we like, isn't it? Okay, uniform electric field. E vector equal to 3 into 10 raised to 3 I caret Newton per coulomb. Write it, draw it. Start drawing a diagram. No diagram, no knowledge, remember. So electric field is in which direction? Towards positive x. Alright? Take it in. Okay, then what's given? What is the flux of this field? Means we have to find electric flux. Through a square. Is a square a flat surface or a curved surface? Flat surface, absolutely sure. Okay, if you're not, this is not the right classroom to sit in. Now, barabar kiddu ne? What to kiddu? If you are not sure whether square is flat or not. Okay. Yeah, so 10 centimeter on a side whose plane is parallel to the YZ plane. Okay, come to this corner. Right, where is the YZ plane? Can you point out the YZ plane? Can you point out the YZ plane? Wall. This wall is the YZ. Clear or not clear?
Yes.
X running that way, Y here, Z here, and Y here. So this is the YZ. Got it?
Yes.
So where is the square? It's parallel to the YZ plane. Okay? So it's something like this. And then parallel to the YZ. How is the square moving? Where is electric field? It's in that direction. Got it?
Yes.
Can you draw this? Do it. Done? Does your diagram look like this? Yes or no? This I am drawing in 3D, of course. That's why it looks like this. Okay?
Yes.
Sure? Actually, from side it looks just like this. But in the main case, square can't check. Are you a square check? Square check? Dekha square. This is the square. I know some of you are thinking, so what આ સ્ક્વેર છે હમણાં અમને કહેતા હતા કે આ ક્લાસમાં ન બેસાય હવે તમારે જોઈન કરવું but the joke will still be on you if you think that બરાબર ને so okay never mind so here what's the angle between okay this is a flat surface field is uniform we are ready to use which formula EA cos theta okay tell me the value electric field in magnitude how much 3 into 10 raised to 3 okay here you only have to put magnitude totally nothing how much area of that surface how much is the area of that surface 10 centimeters in a side so area is 100 centimeters square or 0.1 meter whole square okay okay or not okay now there theta is the angle between electric field and A vector. So electric field is towards the right side. Now area vector is always perpendicular to the surface. So this is the surface. Area vector क्या होता है? Either right side or left side. Is that okay or not okay?
Yes.
Sure. If you cannot imagine, put your book like this and put the pen. See for yourself. Sure. If you take a surface here, the area vector will either go that way or this way, like for this wall. Okay, so angle will be 0. So cos 0. Again, we are taking it towards the right side. I repeat, we are taking the area vector towards the right side. You could take it left side, the answer will be opposite. But generally, I've seen that whenever we have electric field in a given direction and this surface is flat, if the electric field is in some given direction and surface is flat, then we tend to take area vector such that theta remains acute. Okay, it's not a rule. It is not a rule. ઊંધું લો તો આન્સર ખોટો ન જ કહેવાય બોર્ડ એક્ઝામમાં હું એવું લખીને આવ્યો હોય તો કોર્ટ કેસ જે થયો થઈ જાય પણ હું માર્ક લઈને રહું બીકોઝ ઇટ ઇઝ કરેક્ટ ઓકે એવું ક્યાંય લખેલું નથી કે એરિયા વેક્ટર હોય એક્યુટ એંગલ જ બનાવે ધેટ્સ નોટ ટ્રુ but normally people tend to take it like that what is એટલે બુકનો આન્સર એવી રીતે જ આપેલું છે fine so cos 0 understood not cos 180 well what to do next so this is going to be 3 into 10 that is 30 yes or no okay unit what's the unit of flux look at the formula and decide electric field Newton per coulomb okay but basically this can also be written as voltmeter okay not voltmeter the instrument but volt into meter okay why like this why is this unit like this that I'll tell you in second chapter okay don't worry about it right now if you can remember no problem if you can't remember no problem again this is good enough for us okay all right now there is part B that is homework okay part B that is homework fine you have to tilt it by an angle and you have to do it